Saxon's Calculus Lesson 90 is about volume by washers. Now, a washer is, of course, a ring with a hole in the middle. And so they show you what they're talking about in taking two different curves, like so, and rotating it about the y-axis, and that's creating this hole here in the middle and this ring of material then going around. So this is example 1, and I've gone ahead and drawn it, and it says, find the volume of the solid formed by revolving the region shown about the y-axis. And since these are the two equations that we've been given, and we know that we're working on volume, it's going to be based on the circle that's created when it's rotated. So that's going to be the pi r squared. So these equations are going to act as the radiuses that we're going to fill in with that constant of a pi. So we know we're going to integrate. And since I'm rotating about the y-axis, I also know that I have to have it solved, the equation solved for the x equals, so that I'm plugging in the y's rather than the y equals in which these equations are currently given. So if I solved this one, and I'm going to throw my pi out here, for my radius squared, actually, let me do this one. Reason being, this is the outer one, and I'm going to minus the integration of this inner one because this is the bigger one, creating more volume underneath it, and then subtracting this volume off. So if I solve here, that is the square root of y, and then squared because of the pi r squared, and that is going from 0 to 4. And then we're minusing, as I said, the integration, also 0 to 4 of this one solved. So that's going to be 1/2 y, and then that is square rooted as well, and squared because of the, this one should technically have the pi written out there as well. Now, let's work on solving. So we have our pi, and then y square rooted squared just goes to y. So when you integrate that, you get the 1/2 y squared, and then why does that feel like it's backwards from what they did? Let me fix this one. Yeah. Okay, so then that leaves me with 1/2 a y. So when I do that, 1 plus 1 is 2 multiplied here. That's killing that off, making it y squared just a second. I don't feel like it is killing it off. 1. That half is a constant. 1 plus 1 is 2. No, 1/2 times 1/2 is 1/4. Ah, that feels much better. Y squared. Yes, 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 yes. Okay, so now this one is minusing this one. The pi is still multiplying in front of those, and we're filling in the 0 to 4 for both of those. All right, so then this gives me, zeros are gone, so 4 squared divided by 2 is 8 pi, minus, and then the 4 squared, 16 divided by 4 is 4, so minus 4 pi, giving me a total of 4 pi units cubed because it was volume. Okay, now, I should have gone down here. I was picturing doing that, and then I forgot what I was doing. So here's example 2. I'll just have to kind of cram the spacing in. So the region bounded by the graphs of, sorry, I skipped to example 3. Find the volume of the solid formed by revolving about the x-axis, so now we're rotating it this way, shown between the graphs, and they are labeled. So we are going to integrate. And since it's going about the x-axis, this one is the upper, this one is the lower. So we know we have our pi out here, and then our x squared squared minus that same integration. I know the pi is out there. And then that's the square root of x squared. They keep flipping on me visually. No, when I'm rotating this way, no, that's right. That's the x squared one. Goodness gracious. Okay, and then what are my boundaries? Well, it's from 0 to 1. So 0 to 1, 0 to 1. All right, so now that's x to the 4th. That's going to make it 1/5 x to the 5th minus, and that's x, so that becomes 1/2 x squared. They do have it backwards. Yeah. All right, plugging in the 0 to 1, multiplying all of that still with the pi. That's weird. Unless, wait a second. They do draw a little box in here indicating to me which direction I'm supposed to be going. So since the long one, the length is connecting to, well, the first connecting side is to the, okay, I think that is why they flip-flopped it. Let's just keep going. So obviously the 0 isn't going to matter. The 1 plugged in is basically giving me 1/5 minus 1/2. So common denominator 10, 2, 10, and 5. Oh, well, here would be I would know for sure once I got to this point, because 2 minus 5 can't give me a negative answer. I can't have that because I'm dealing with volume. I can't have a negative volume. So let's just change that to negative and positive. They just automatically fixed that when they did it. I was going by what I thought it was, but here I've proved it's not. So now it's 5 minus 2, which is 3/10 pi, 3/10 with the pi, and then our units cubed. Okay, and now let's look at example 3, which I went ahead and drew out as well. So it says the region bounded by the graphs of y equals x squared plus 2, that's the parabola, and x equals 0, so that's this y-axis. Sorry, yes, it is, but it's meaning from here to 1 because the next thing it says is x equals 1. So we're talking about this section in here, and the y equals 1/2 an x plus 1, which is this line, and that is revolved about the x-axis. So I want to draw, I didn't finish drawing this part in. It's this line here, so it's this section that we're revolving about the x-axis. Find the volume of the solid revolution generated. Okay, yes. So we are again going to integrate. We're going to have our pi, and we're going to have our x squared plus 2 squared, minusing the integration with the other one, which would be the 1/2 x plus 1 squared. And then we're going from 0 to 1 for both of those. And now we do need to work this out. So we're going to get x to the 4th plus 4x squared plus 4 minusing, so a 4th x squared, and that minus is distributing. So when I multiply these, I get a 1/2 x doubled to a whole x, except I'm minusing that whole x, and then 1 squared is 1, and again, we're minusing that. So we're integrating all of those parts. So this is, oh, and we still have, of course, the pi with all of that. Okay, so now this is 1/5 x to the 5th plus, and then 1, so 4/3 x cubed plus 4x minus, and that goes to 3, and 3 with the 4 makes a 12th x cubed minus, that's x, so 1/2 x squared minus x. And we are plugging in from 0 to 1. Then the 0, all of them have an x. Yes, so the 0 is irrelevant. When we plug in the ones, we're basically just dealing with the fractions. So 1/5 plus 4/3 plus 4 minus 1/12 minus 1/2 minus 1. Now I could do a common denominator with all that, but it's easier for you to just punch it into your calculator. And so you're going to end up with 79/20. And then the pi is still with that. And then that's units cubed.